So here's that question, the difference. How can I teach my kids to get the right answer? How can I use this problem to teach the math they're supposed to learn from it? So let's just look at some examples. We've all taught adding fractions with unlike denominators. We all have methods. This is a common method. You may not recognize the name, but you'll recognize the method. Works like this. You draw the wings, and then you draw the body. You draw a plus sign for the antenna to remind you, a multiplication sign for the tail. Then you multiply on the wings. 4 times 1 is 4, you write it down. 3 times 3 is 9, you write it down. 9 plus, I remember, 4 is 13. Down here, I remember to multiply. 4 times 3 is 12, you write it in the tail. Answer, 13/12. Correct. Works every time. What the hell does this have to do with algebra? This is how the kids you're getting in algebra got past the fractions test when they were in 6th grade or 5th grade. But when you get them, they don't know fractions. How did they pass the test? They passed the test doing it like this. So this is not mathematics. This is answer getting. This is clutter in the curriculum. This takes 3 or 4 days to teach, gets them past this year's test or this month's test, wastes time. To teach them the mathematics they're supposed to learn when they're adding fractions with unlike denominator would take longer and would be harder for them, but you'd be teaching them algebra. This is TIMS. This is the easiest fraction item on TIMS, the easiest fraction item with unlike denominators. If you were a butterfly method, you'd be lost. So this problem, I put this up here because this is a good distinguisher. If it's an answer-getting tradition like this problem is a good detector. So in a lot of countries, 80–90% of the kids got this right. In some countries like ours, it was down around 20. So it was one of those toggle items. FOIL method. This is algebra. You know, first out or inner last, everyone does it. Not you. It's faster and more reliable than teaching that this is an application of the distributive property. Because to apply the distributive property, you have to do it once, and then you have to do it twice. And the second time you have to do it 2 times, because there's 2 terms. The FOIL method works all chapter long. Next chapter, you have to multiply a binomial times a trinomial. What happens to the FOIL method? Distributive property still works. The way the distributive property works with polynomials, it's very deep, and it turns out to be where integration comes from when they get to calculus. I mean, it's all over the place. It's as the foundation. Canceling. So we all tell them, kids, you know, it's nothing wrong with the word cancel. It's casual. You know, this x cancels this one, this x cancels this one. There are 3 left, so the answer is x cubed. That's correct. What do they do? Here's you have x fifth, this one, this one. They all cancel out. Answer? 0. About half the kids pick 0 on a standardized test for this. It's on most tests will have something like this. Why are they saying 0? It's just a procedure. They don't understand the meaning. They should look at this. Anything times its inverse is 1. You don't even have to do anything. If it's the same on the top and the bottom, it's 1. So what's canceling really about? I'm not against using this word, but they should understand what it is. X over x equals 1. It's the identity element for multiplication. The reason I went through all of this is, you know, the mile wide, inch deep, we all hear that and we think someone's doing it to us. But one of the things we need to do is think, I'm doing it. All of us are doing it. Teachers are doing it. Principals are doing it. Districts are doing it. Textbooks are doing it. Tests are doing it. Standards are doing it. But this is how teachers do it. All these things, canceling isn't math. So you added it to the curriculum. FOIL isn't math. You just added something to the curriculum. Most of the time, you're not only adding, but you're leaving out the math. Teachers have their part in making things mile wide, inch deep, and mainly it comes in the form of methods for answer getting that avoid the math or hide the math.